Good morning, everyone. So today we are going to do the final group in the module 2, that is representative elements part 1. So in that, the final group that we have to look into is group 40. Okay, so group 40, as you all are aware of, is basically the carbon family. Okay, so it includes these elements, that is carbon, silicon, germanium, tin, and lead. Okay, these are the elements that you find in group 40. Now, if you talk about the general electronic configuration of group 14 elements, the general electronic configuration is nothing but NS2, NP2. Okay, so accordingly, you will have, in the case of carbon, it would be 2s2 and 2p2. When you come to silicon, you will have 3s2 and 3p2. Obviously, before this, you will have here in this case, it would be helium. And here in this case, it would be neon. Okay, this would be the general electronic configuration. So if you compare the carbon and the silicon, you will find that in third shell, you will have an empty 3D subshell present in the case of silicon. And that particular advantage you will not find in the case of carbon. So this particular thing we will be discussing in one of the examples that we are going to study later in this particular group. And obviously the rest of the elements you can write similarly the electronic configuration. The only difference that you will find in the case of germanium, tin, and lead is that they all have their penultimate d subshell filled with the electrons. They are all fully filled, and that gives rise to the inert pair effect that you also saw in group 13 elements. Now here I have written down the major oxidation state that these elements show. So from carbon to tin, what you find is that the major oxidation state that these elements show is the +4 oxidation state. However, when you come to the lead, the oxidation state that is more preferred is the oxidation state 2. And that we can easily understand because in the case of lead, you have now the F subshell being fully filled. Now F are very poor in shielding the nuclear charge. So that's why you will have these S electrons being holded very close to nucleus. So only available electrons are the electrons that are present on the diffused p orbitals. Okay, and that is why in the case of lead, you have the participation of the p electrons only and leading to the preferred oxidation state of +2. And these particular oxidation states are kind of less preferred, but you find compounds with these oxidation state in the case of germanium and stannum also. That can be understood because in this case also you have the penultimate d subshells fully filled, and d subshells are also poor, have poor shielding effect, and therefore the p electrons are more available. So in germanium and tin also you will find the +2 oxidation state getting in the various compounds that these elements form. Now, looking at in general about these elements, what do you know about that? So carbon is an element that you will find widespread in the nature. So you will have a branch itself of compounds that are carbon compounds, and that branch of chemistry is called the organic chemistry, and it's a very vast branch of chemistry. And now you have lots of sub branches of organic chemistry that are involved. So that much importance we have for the carbon as an element. So you definitely have come across various compounds of organic chemistry so far in your various chemistry classes. Apart from that, we have inorganic compounds of carbon as well, like carbon monoxide, carbon dioxide, coke, graphite, okay, and some things like carbonates, okay, calcium carbide, calcium cyanamide, calcium carbon disulfide. So all these involve carbon as an entity or the element in these compounds, and they are in an inorganic sense, you will find them. Apart from that, another very widespread in nature you will find is the silicon element. And silicon, usually you will find it more in the form of silica, that is your sand, which is nothing but SiO2. Silicon you will find otherwise also in this form. They are used in cement, ceramics, bricks, glasses are basically silica only. And then these days you have in the corners, you might have seen certain gel type thing the workers using to paste the glasses, okay, on the windows, okay. And these gel type sticking material are basically silicon based polymers, okay. So we have silicon polymers which are used these days for various construction work. So you have silicon based polymers also being made to do all the kinds of construction works as well. So silicon is also another very important element in this particular group. Coming to the tin and lead, they are kind of very ancient elements. They have been known from almost like biblical times. We can say that it is a very old metal, it has been used quite often during that time. And one of the important highlights would be the Hanging Gardens of Babylon. These are one of the wonders of the world. And here in these hanging gardens, the bottom of these hanging gardens are like coated with lead, okay. And why they are doing is because in order to prevent the seepage of water from those gardens towards the, so to prevent the seepage of the water, you use lead as a coating. So here you will, so these elements are therefore very, very important elements, and you will find their uses more as you study more about these elements in this particular group. Now, further, let us also look briefly about the allotropy of these elements. So, carbon, as you can see, they are basically, you can find that they are there in the diamonds. Then graphite also have two forms that are alpha and beta form. In one of the constructions of the diamond structure, you will have rare type in which the structural entity, that is hexagonal form of the carbon interlinking, you will find in the diamond. Apart from that, more recent allotropy of carbon is nothing but your fullerene. Coming to silicon, silicon has basically two different types of allotropy. One is the amorphous form, okay. Another one is crystalline form, and they are also called as adamantine. Coming to germanium, the acid doesn't show any allotropy, but they have a very unusual structure. As we discussed in group 13, when we talked about gallium, they have a very unusual property that usually when liquid forms a solid, it shouldn't expand, but rather it should contract, right? But germanium, like gallium, is kind of have an unusual crystal structure, because of which these, when they go from a liquid state to a solid state, they kind of expand. So like in the case of gallium, when we studied there, it is kind of diatomic gallium atom spread over the crystal structure. which is giving the expanded expansion happening in the case when going from a liquid state to a solid state. Similar kind of structure you can expect in the case of germanium as well. So like gallium, germanium also is an element which, when going from a liquid state to a solid state, it expands. Coming to tin, they are having the allotropic form, that is the gray form of tin. There is a white form of tin, and there are two different white forms. One has a tetragonal shape, another has a rhombic shape. And this white rhombic form of the allotropic form of tin, they are also called as beta tin. Okay, and this gray cubical form of the tin is also called as alpha tin. And these have a diamond crystal structure. However, these white forms of the tin, white allotropes of the tin, they are more metallic in nature. So as you move down the group, as expected, the metallic character increases. So tin shows more metallic character because they are coming towards the bottom of the group. And lead, mostly they don't have any allotropic form. They are mostly existing in the form of a metal. Okay, lead is a metal itself. So you find metallic form more of the lead element. Okay, so this is the basic introduction that I would like to give to you regarding the group 14 element. So in the next class, we will start with the anomalous properties that is exhibited by the carbon, and related to that, we will see some of the properties. Thank you very much for your kind attention.